Hey, what's up, Brandong? Let's talk about muscle protein synthesis and motor unit recruitment. So, first, muscle protein synthesis, just think of this as muscle growth. For most people, we go through this balance up and down of muscle protein breakdown and then muscle protein synthesis. So we're building muscle, losing muscle, building muscle, losing muscle. And that kind of looks like this. All right. So like let's say that this horizontal line is our our balance point. Down here, this would be breakdown. This is muscle protein breakdown. But for most people, we're also building muscle at about the same rate. So over time, we kind of maintain the tissue that we have. But when we lift weights, it makes the muscles that we used during the workout more sensitive to the presence of amino acids in our blood. So when we eat protein in our meals, this growth area here that's the same size normally as loss spikes up. And then so we have more growth than we have loss. And over time, what this does is it results in our muscles being bigger. So these spikes right here would be when we're eating food. So you go to the gym, you lift weights, it makes your muscles more sensitive to amino acids in your blood. Your body recognizes those amino acids and says, all right, time to grow. And then it grows. So when you see muscle protein synthesis, all that means is your body is building new components of your muscles so that they grow just a little bit over time. That's all that is. The complicated part of this question is, how do you build a workout program or go into the gym to make sure that you're maximizing this? And that's what starts a lot of arguments here on TikTok, Instagram, Reddit, whatever, but we won't talk about that right now. Next is motor unit recruitment. So for this, just think of this as how much of a muscle is actively contracting. Let's say this is a cross-sectional view of a piece of muscle right here, right? This is going to be made up of lots of groupings of muscle fibers. We'll have big groupings and small groupings, all different sizes in here, right? We have, it's sort of on a spectrum, but type 1 muscle fibers that are slower, but they're really good at long distance, long duration activities. They burn a lot of oxygen because they're very oxidative and they don't grow very big. Those type 1 fibers, we're going to see lots of those in these smaller groupings. And then type 2 fibers get really big. They're really explosive, really fast. We'll see more of those in these larger groupings. Our body, whenever we're doing, like let's say you're doing some bicep curls and you're fatiguing over time. You're doing a set of 20 reps of bicep curls. At the beginning of that set of 20, you're only using these little groupings here, these type 1 fibers. Over time, as you get more and more tired, you start to incorporate these bigger groupings of the type 2 fibers that grow over time. So if like, let's say here's our rep counter, here's 1, here's 20. Type 2 fibers don't really start to get incorporated until over here. Motor unit recruitment is saying, as we're moving along this rep count, how much of this muscle fiber, what percentage of all the muscle fibers in here are being activated to contract and produce force. So low motor unit recruitment would occur with like really lightweight. High motor unit recruitment would occur with heavyweight or really explosive or fast weight. So on the other video that you commented on, if we have high levels of motor unit recruitment, that means that all of the fibers within a muscle are actively contracting. They're actively experiencing tension, and that tension then leads to growth in most cases.